Okay, so we're going to go and look at parts 2 and 3. That's about expanding and contracting logs using those rules that we talked about again. So off we go. So keep in mind as we look through this data, we're going to continue to use these little rules that if you have things together as a single logarithm, we could separate them and make them multiple logs, or we could actually take multiple logs and putting them back together as a singular log. So for number 2, the idea is we're going to take this big, tight bunch of stuff and expand it into little bite-sized pieces. So I'm going to start by saying I've got the log base 2 of 8. I know I have that, but there's a plus here because 8 is being multiplied by that x cubed. And remember in our properties, a plus comes when you multiply, right? This rule number 1 is that if you have a product, you could separate it as a sum of individual logs, plus the log base 2 of y to the 7th. Now, I'm not done. I'm going to do a little bit more. We also have a subtraction at play because there's a division here, and we've got the log base 2 of x plus 1. And I'm going to write that as the 1/7 power because remember, a 7th root is a 1/7 power. Now, as we go through that, I'm going to skip this one for a moment. But remember, rule number 3 says that if you have a power, that power can be brought to the front to simplify things. So instead of thinking about the log base 2 of x cubed, I'm going to think about the log base 2 of x, but just multiplied by 3. Here we're going to have 7 of those log base 2's of y's, and down here we're going to have the log base 2 of x plus 1. But instead of to the 1/7 power, we're going to bring it in front. Now, the only thing I'm going to say is on this one, I'm going to do one little trick because according to what we said above, the definition of a log is what is the power on that thing? That a raised to some power is that value. So 2 raised to some power is 8, and that something would be 3. Now, that doesn't look beautiful to most math students, but it's bite-sized little simple pieces that each individually are fairly easy to handle. The only difference with part B is that we now have a natural log, which means we're talking base E. So we would have the natural log of 5 plus the natural log of e to the 4th plus the natural log of t to the 5/2, because remember it's a square root. Now there is confusion on the next portion here. We're going to have minus the natural log of a, and we're also going to have minus the natural log of m. And a lot of times people are bothered because you're saying, well, aren't a and m being multiplied together? Well, yes, they are being multiplied together, but they're being multiplied in the denominator. So we want to consider them both as negatives. What we could do, though, is we could put a parentheses around this and have the negative outside. I just think that's a little more confusing. And so I'm just going to do an ever so slight simplification because this is base e, so the exponent is 4 plus ln of 5 plus 5/2 ln of t minus ln a minus ln m. And we are done. We have separated that into bite-sized pieces that mathematically are a little bit easier to handle. Now, when it comes to number 3, it's just the idea of let's go the other direction and kind of put them back together and make things look a little bit nicer. So purposefully, I was going to do this one first, and you'll see why in a second. So notice that all of these are base 6. That's going to make life a little bit easier. And I know that's going to seem strange that I'm going backwards, but I've got an x here. There's a plus, and that means we're going to multiply it by y cubed. We're going to divide by x plus 1 because remember, subtraction leads to division, and we're going to subtract, again, the square root of k. So that's a division again. That was pretty straightforward and simple. The part that's a little weird, and that's why I decided to do this second, is a lot of people don't realize that sometimes you can do things in varied orders. And what I wanted to highlight with you is that These values right here mathematically are like terms. If I have 2/3 of something and I lost one of those things or 3/3, I could put them together and say I have lost 1/3 of those things. If I have an entire natural log, but I lost half of one, I would have half of one. Now, if you didn't see that, it's not a big deal. But it was faster if we could write it this way. Remember, t to the 1/2, that is a square root. And this is a cube root of y, and that's in the bottom. Now, a lot of people do not actually see that little trick about combining those like terms at the time that I did. A lot of people go ahead and do this a little bit differently. I'm going to do this on a separate piece of paper. What a lot of people do is they say, well, fine, I've got the natural log. I've got y to the 2/3 power. Let's say I'm going to just put y to the 2/3 here. I'm going to have a t here. I'm going to have a y here, and I'm going to have a t to the 1/2 there. And this is all great. This is fine. But remember, rules of exponents say when you have the same exponents, you can subtract, and 1 take away 1/2 is going to be 1/2. 2/3 take away 1 is -1/3. But anytime you have a negative exponent, it is better to rewrite that in the denominator. So this is going to be a y to the 1/3 in the bottom, which is a cube root of y. Notice we have the same answer. We can either simplify early or we could simplify late. It gives us the same answer, and it's perfectly fine. So our last one, this is the trickiest one. And the problem here is that we have varied bases throughout this thing. And so notice that we have log base 4 in both of these places, but a log base 16. And we really need them to be that same base. So step number 1 is I'm going to make everybody log base 4. But my change of base formula says I can take any base that I want as long as I take that base that I want, the log of the original question and the log of the original base right here. So that's going to be the log top and bottom. I desire a base 4, and my original question was x, and my original question was 16. Well, that being stated, I've got the log base 4 of r minus 2 log base 4s of p. Well, 4 to the 2 power is 16. So this entire base is a 2. All of that is a 2. And so 1/2 of 2, see the 1/2 there and the 2, they cancel out and make it 1/4. And now we have all of these things with a shared base. And I could say it's the log base 4. I've got an r on top. Oops, let me move that up a little bit. I've got a p squared in the bottom, and notice it was in the bottom because it's negative. And I've got a 4th root of x here. Now, I don't want to go on too long, but as it turns out, I'm going to go ahead and redo this problem, and I'm going to embrace a big base instead of a small base. And this is going to bother some of you, but bear with me here. I'm going to go ahead and make everybody in my story log base 16. Okay. Now, this is going to bug you a little bit, but it's all right. 16 to the 1/2 power is 4. But if there's a half in the bottom, dividing by a half is the same thing as multiplying by a 2. There's a half in the bottom, but dividing by a half is the same thing as multiplying by 2. And all of a sudden, you'll notice that I'm going to have fewer roots and things in this problem. And so it's kind of nice. This is going to be an r squared, not an r, but now an r squared. It's not going to be p squared. It's going to be p to the 4th in the bottom. And this is, instead of a 4th root, is going to be a simple square root. It really doesn't matter which one you pick. They both work equally well. All right. Hopefully that helps. I'll see you back in class. Bye-bye.